Hello everybody, thanks for attending this webinar. My name is Pradeep and I work with Alibaba Cloud as Big Data and AI Architect. I have more than 15 years of experience in this field, and in this webinar I have a twofold agenda. First, I would like to provide a brief introduction to Alibaba Cloud's two cornerstone products, Max Compute and Pi. And then I will showcase an end-to-end scenario where we will predict loan default propensity using Pi. One of the flagship products of Alibaba Cloud's big data platform is Max Compute. Now, Max Compute scales at petabyte level, so it can handle large size. It has three kinds of engine built in. It has Graph, it has SQL, and MapReduce. Since it's a platform as a service offering, it abstracts the infrastructure layer and you only pay for what you use. Max Compute also has a rich interface that enables you to interact with common languages like R, Python, or Java. The second product is Pi, also called as Platform for AI. It is the machine learning product from Alibaba Cloud. It has 100 plus data science modules pre-built in it and a catalog of 30 plus machine learning algorithms. A cool drag and drop interface that enables you to create rapid experiments and deploy it. And it will soon support deep learning frameworks like TensorFlow, Caffe, MXNet, and so on. Like I was saying, Pi offers a rich catalog of machine learning modules, the whole nine yards. It has algorithms for regression models, binary classification, multi-class classification, time series, network analytics, text analytics, clustering, recommendation, and so on. Now, having got an overview of what Max Compute and Pi is, now let's get down to the scenario. In this end-to-end demo scenario, we will take a banking case and predict what is the likelihood for a customer to default based on various characteristics and input. Now, before we get there, let us define what is the process that we will follow. Generally, when we deal with machine learning problems, we start by defining the business problem. For the business problem, we need to set clear criteria and translate that into machine learning problems. A machine learning problem may be that I want to have visibility of which customers to target and so on. Translating it into machine learning may be something like we need to do a classification of customers who would buy a product or not, and what is the likelihood of somebody buying the product. Once the business problem can be decomposed into multiple machine learning tasks, each machine learning problem can have one or more models employed to solve it. Once the machine learning problems have been defined, then we need to drill deeper into the data. Data understanding should be specific to the problem at hand and help us to strategize the right kind of analysis we want to do. While we do data preparation, we also do a lot of exploratory data analysis. It could include statistical analysis, drilling down into outliers, and shortlisting the predictive methods that we would use. Typically, modeling and evaluation is only 20% of the work, and it's an iterative cycle wherein once the evaluation of the model is done, we would go back and try to improve it if required. Now let me explain the demo architecture we will be doing for this scenario. So There is a loan data set which I have already uploaded into OSS, which is the standard object store for Alibaba Cloud. And then from OSS, I have taken a tool called as DataWorks, which will ingest it from OSS into Max Compute. Now, the data is already in Max Compute. We will use Pi to create the predictive models, and Pi will read the data from Max Compute. Once experiments are shortlisted, we would then deploy the experiments back into DataWorks. The experiments would also then output the prediction for new data sets. Following is the loan dataset features. It has a unique column, loan ID and customer ID. It has a few binary columns like tax liens and whether somebody is bankrupt or not. A bunch of numeric columns like credit score, years in current job, annual income, and so on. And categorical features like home ownership, purpose of the loan, loan term, uh, and loan status, which is our target. Loan status has two types. One is fully paid, and the second one is default. So we need to predict if somebody will default or not, and hence loan status is the target for this scenario. In general, there are two types of machine learning problems. One is supervised learning, and second one is unsupervised. In supervised learning, specifically, you have a target. It could be, and within supervised learning, there are essentially two types. One is a classification model, and one is the regression model. Unsupervised learning generally don't have any target. They are meant more for exploratory purposes. Um, um, Categories like clustering or link prediction um, are part of unsupervised learning modules. So in this case, we will be creating a classification model wherein we will predict if somebody will default or not. Now, with that, I would like to jump into the demo of Pi. So what you see is the canvas for Pi, and we will start by creating a new experiment. So let me name this experiment as loan prediction webinar. Now the experiment has been created. Let's talk about what we will do for data exploration and pre-processing. Now we will perform a series of steps wherein first I will get the data from Max Compute, and then I will use SQL to transform the data. We will fill any missing values because algorithms sometimes don't work well if there are null values. We will do some exploratory data analysis by creating scatter plots and histograms, and we will perform a process called as normalizing. So let's get started. First, I would like to read the data from Max Compute. So let me just read it using this module called as read Max Compute table. I will drag and drop this onto the canvas and provide the name of the table, which is loan. Rename this module as read data. Let's explore it. As you can see, we have columns like loan ID, customer ID, status of the loan, um, credit scores, and a lot of other features which we will use for prediction. Next thing we want to do is perform some transformations using SQL. For that, I will use a module called as SQL Script. I can find this by just typing in the search button. So let us connect read data to SQL Script. I have already done the SQL script here. Let me just copy and paste it onto the module. Now, what this SQL does is it is doing some case statements to ensure that when the loan amount is a high number and the status is fully paid, then default it to zero, else default it to the loan amount. I'm doing some conversion of data types, and then I'm creating f- the target field called as is default. So if the loan status is fully paid, then it is zero. That means that he has not defaulted. Or if it is not fully paid, then it is one. That means the customer has defaulted. Let me save this SQL component and go back. So next thing we want to do is fill any missing values. Now, before we do this, let us run this experiment till this step. I will just right click and then say run to here. So what Pi does now is that it will trigger this process, and it will create temporary tables in max compute to run the process end to end. Okay, now SQL script is complete. Now let's explore the data after the output. So we have a new column here is default, which is 0 and 1 depending on the loan status field. Now let us do some filling the missing values. For that, I have a module called as missing value filling. Let me drag and drop onto this canvas, connect it to uh, fill missing values, and select the fields that I need to uh, provide. So I would provide fields like credit score, annual income, number of open accounts, um, balance, maximum open credit. And if there are any missing values in this, I would like to replace it with uh, a custom field, and I will default it to zero. So once this part is done, let us do some exploratory data analysis. There are a bunch of exploratory data analysis modules which are pre-built in Pi. Like you could do covariance, chi-square test, full table statistics, box plot, scatter plots, t-test, normality test, and so on. In this case, I will just use a scatter plot and a box uh, and a histogram. So let me connect the output of the missing value into these two components. So for scatter plot, I would like to select the numerical columns and use a class label of is default. And for histogram, I will select the um, numerical columns again. Let us run these two components now. I can specifically tell Pi from which point of the experiment it needs to start to run. So let's run from filling the missing value. Okay, Pi has now completed the running of scatter plots and histogram. Let us explore the output. You could explore the output by clicking on View Analytical Reports. Now here is the bunch of scatter plot that Pi has built in from scratch. Let's look at histograms. Now I could see the distributions here and slide it to change the bins. I could also download it as images. Now that we have finished with exploratory data analysis, let us look at the process of normalization. Normalization is a machine learning process to rescale values in data. If the numeric data elements have different ranges, then it generally makes sense to bring all the numeric data in a similar range. This process improves the model performance as it eliminates any skew in data. It also negates the influence of outlier values on the model. There are many methods for normalizing data like z-score, min-max, etc. Here we will by default use min-max for normalizing. Now for normalization, I will use a module called as normalization. Let me drag and drop this onto the canvas. The output of the missing value goes into normalization, and I will select the numeric columns which are used for normalizing. Let's run this module now. Now that normalization process is complete, let us now go to the next steps. So typically when we perform a machine learning task, we split the data into two parts. The first is a training set on which we will train the model, and the second is the test set wherein we will evaluate the model based on unseen data. The performance of the model is always evaluated based on the test set. Let's do the splitting in Pi. So for that, I will use a module called as split data. The output of the normalizer would go into split. And here there are multiple ways to split. I will split by ratio. 70% would go into training and the remaining would go into testing. There are tons of pre-built algorithms available in Pi for binary classification, regression, network analysis, time series, and so on. You will choose two algorithms, logistic regression and random forest. Train the model using both these algorithms and then choose the best one that has the top AUC score on the test set. So let's get started. So first thing I would like to choose algorithm logistic regression, which can be found under the machine learning module. Let me drag and drop logistic regression. The split has two parts. One is the train dataset and other is the test dataset. So we will train the logistic regression based on the training set. Let me select the columns that I need, only the numeric columns, and then the target is default. Now, once it is trained, we need to do the prediction on the test set. So there is a module in Pi called as prediction. I would use that. One part of the input for prediction is my trained model, and the other part is the test set. So as the prediction is done, we would then want to evaluate the classifier, and there are multiple evaluation modules pre-built in Pi. So for binary classification, I will use binary classification evaluation. And the way we will do evaluation is uh, we will compare the each default value with predicted result. Now this is how we train logistic regression. We will also now train the model based on random forest. So let us find the random forest algorithm. The first input would be the training data set. I would select a few feature columns for it to train and create the model. I can also take in numeric as well as categorical variables. So let's put in the purpose of the loan, then home ownership, and the term of the loan. I need to give a label column. So this is again is default. So once it is trained, I would want to do the prediction. One input would be the trained model, the other input would be the test set, and we have to do the evaluation on random forest model as well. So evaluation would be done by comparing the values in each default with prediction result. Now let's start to run this from split module. So this will take some time and run it end to end, all the way from training to testing and evaluation. The experiment has finished its run. So let us see how both logistic regression and random forest models have fared. So for the logistic regression based model, we see the evaluation report, and these are the bunch of indexes that we use for evaluation. And you can see that the AUC score here is 0.64, which is not that great. Our target AUC is around zero point 0.8. Let us see how binary classification from based on random forest has fared. So here we can see that the AUC score here is much better. It is around 0.80. So we will use the model based on random forest for deployment. So here is an end-to-end flow of our experiment. So we started with some basic SQL transformations and then filled up the missing values, did normalization, scatter plots, and histogram as part of EDA. And then we split the data into two, experimented with two algorithms, logistic regression and random forest. And we found that our target AUC was zero point 0.8. Random forest has actually met that number. So we will use a random forest based model for deployment. Now the way we will do deployment is we will choose the best model and use based on the best model we will create a deployment experiment, and the predictions can then be written back into max compute. We will deploy this model in DataWorks by just one click of a button. So let's get started to create the deployment model. Now let us start to deploy this model. To deploy the model, we need to create a copy of this and then remove all the unrequired components and just load the new dataset to do the right prediction. So I have already created a sample of how the deployment model would look like. It will take in the new loan dataset, perform the required SQL transformation, fill any missing values, do the normalization of data using the random forest model that we have generated. It will do the prediction and filter any columns that we don't need and load it into max compute again. So it takes in from new data set and then loads it into a new table called as loan predict. Now, if you want to deploy this model, all you have to do is click this button and it will schedule the machine learning task in DataWorks. So let's do that. The deployed model deploys it in DataWorks. This is the model that has been deployed. Let us see what this contains. So here we need to select the algorithm that we want to schedule to run periodically. So I will select the loan prediction deploy, and it will generate a flowchart of how the deployment will be. So like we discussed, it will take in the new loan data set, perform the SQL transformation, fill missing values, do normalization, and using the random forest, do the prediction and write the output back into max compute. So you can schedule when you want this job to run based on the activation dates, periodic scheduling. It can be day, week, month, or minutes, and so on. And periodically, based on the schedule, the end-to-end flow will run in DataWorks. So that brings us to the end of this webinar. So here are key takeaways from this webinar. The first thing is Pi enables machine learning at scale. We saw how Pi uses max compute engine and it can scale at petabytes level as well. Second, we saw that how easy is it to use Pi. It's a drag and drop interface with no requirement of developing code. It has rich repository of pre-built models, pre-built algorithms that you could use. You could do your end-to-end flow like data processing, data transformation, and so on. Scientists can then focus on the business problem rather than getting bogged down with the code. And finally, we also saw that it enables rapid deployment of model. By just one click of a button, you could deploy the model into production and save a lot of time, thus enabling quicker turnaround of data science projects. With that, we come to the end of this webinar. Thank you.
Hello, this is Pradeep again. I will now be answering your questions today during our Q&A session. So let's have the look at the questions that have come through. So the first question I've got is there a manual or tutorial on the steps you follow, preferably with Dataset? Now, this recording will be available offline. So you could follow those steps by having a look at it again. So that is something that you could use. So second question I have is, will Pi support deep learning frameworks? Yes, Pi does support deep learning framework like TensorFlow, Caffe, etc. But it is only available in China as of now, and it will be released internationally in a few months' time. So one more question I have is, how does AI platform compare to other products in the market? Yeah, so this is a very interesting question. Every product has its pros and cons. So what we differentiate Pi is two couple of things. Number one is Pi is used for doing machine learning at scale. So if your data sets is huge, it can even scale at petabytes level as well, which is kind of a bottleneck for some of the other products out there, which is our first differentiation. The second one, you might have seen that it's a drag and drop interface. So it brings you best of both worlds, wherein it can scale as well as it's a drag and drop interface, so you don't get bogged down by doing code, etc. Other platforms that I've seen, you need to actually code a lot. So it is more focused towards developers, whereas Pi is focused towards more traditional data scientists as well as business analysts. So those were the questions that I've had. So that is the end for today. Many thanks for listening and providing your questions. Again, please note that a recording of this webinar will be available tomorrow. Thanks again and have a great day.